Today we're going to look at how to multiply binomials using generic rectangles. And this is very exciting. It's our first look at parabolas and quadratic equations. So we're looking at it as a length times a width of a rectangle. And then what we're going to be doing later on is graphing these and looking at them at parabolas. And this is one of my favorite topics that we're going to be working on this year. So it's very exciting. So we're going to be using generic rectangles in order to make this happen. So our very first example is x plus 8 times x plus 2. And when we have a quadratic in this form, it basically tells us where our quadratics are going to cross the x-axis on two different spots. So in this case, it's going to cross the x-axis at -8 and -2. So a little spoiler alert, because we're going to be working on that a little bit later in chapter 6. So when we do use this, last class we looked at the distributive property when we look at it with one item in front of a set of parentheses. And here we have two or more items. We call this one a 2 by 2 because we have two terms in one set of parentheses and two in the other. So when we have this type of thing, we use a generic rectangle to multiply because it's more multiplication problems. So here's how we multiply binomials. Our first step is to draw a generic rectangle. Now this is a generic rectangle. It's basically a square. It's basically a square cut in half and half again. And then we put lines on the bottom, 2 lines on the bottom and 2 lines on the side. So if we were in the classroom, I'd give you a whole bunch of sheets of these to start with, but you're just going to have to draw them on your own. They don't need to be perfect. You don't need to use a ruler. Just go ahead and draw a square with that plus sign in it. I will be looking at your work for these because it's nice to see what common mistakes are to make sure that you are doing these problems correctly. So you're going to draw that on your paper. Now it's time to set up the problem and put the binomials into the generic rectangle. Now they actually go on the outside. So the terms from the first one, your x plus 8, is going to go on the bottom of your rectangle, one term per space. So we're going to put an x in the first column, and we're going to put an 8 in the second column. Our third step is we're going to put the terms from the second set of parentheses up this side, and this is just for consistency. So we're actually going to start at the bottom, and then we're going to put our x at the bottom left, and then we're going to go to the upper left, and that's where we're going to put your positive 2. So the x is going to be on the bottom, and your positive 2 is going to be up top. Now, you're going to be able to get the right answer if you put these numbers in different order. However, this is the way I'm going to be solving them with you. So it's easier if we're looking at the same type of problem. So x goes in the bottom and the 2 goes up top. So we've set up our problem. Now, step number 4 is we're going to multiply. Now, what are we going to multiply? Well, our very first item that we're going to multiply is we're going to multiply the x by the x. So we're going to take those outsides, we're going to bring them together, and where they meet up is going to be our multiplication. Now, people get this wrong all the time. The wrong answer is 2x, and that's because x plus x, if we have an x, we have another x, we have 2 of them, is 2x. However, we're multiplying. So x times x is x squared. Remember exponents, x times x, the base stays the same. There's 2 of them, so that's our power. So x times x is x squared. Next, we're going to go ahead and we're going to multiply again. Now, what are we going to multiply? Now we're going to multiply our 8 times our x. So we're going into that corner of our generic rectangle. 8 times x is 8x. Now we're going to, shockingly enough, multiply again. Now we're going to multiply your x times your 2. X times 2 is 2x. And we're going to finish up by multiplying a 4th time. And that is 8 times 2, and our 8 times 2 is 16. Now, we kind of clear our head, and we're like, we're done multiplying. Now it's time to add or combine like terms. So remember, we're going to write this as a sum. Now remember as we go here, that as we're adding, we are combining like terms. So we can only combine terms that have exactly the same base with exactly the same power. So in this case, my only 2 that are the same is my 2x and my 8x. So we're going to go ahead and combine those together. So my answer is x squared. There's no other x squared, so it stays x squared. 8x plus 2x is 10x. And then there's nothing to combine my constant with. So that is going to be 16. So our answer for this problem is x squared plus 10x plus 16. And the 16 actually tells us where this parabola is going to cross the y-axis. It has a y-intercept of positive 16. Okay, let's go ahead and give one a try. Here's our second example, 2x minus 3 times x plus 4. So once again, our first job is to draw our generic rectangle and then set up our binomials outside of the generic rectangle. We have 2x minus 3. Now notice that minus 3, we include the sign to the left, so make sure that that is negative. And then we go up the side, we have x plus 4. Now it's time to multiply. X times 2x is 2x squared. X times negative 3 is negative 3x. 2x times 4 is 8x. And 4 times negative 3 is negative 12. Now we're going to go ahead and bring it back together, combining like terms and adding. So we have 2x squared. Our like terms are 8x minus 3x, which is positive 5x, minus 12. So our answer is 2x squared plus 5x minus 12. Be careful with your signs. Our last and third example is negative 3x minus 1 times the quantity x squared plus 2x minus 3. Now this is not a parabola. It's not a quadratic anymore. Quadratics are only 2 by 2s. So we are going to change up our generic rectangle. We have a 2 by 3. There's 2 terms in the first set of parentheses and 3 by the other. So we draw our normal generic rectangle, but we know there's not enough room for our 3. So we are simply going to add on another column and another line underneath. So as you can see, there's room for our 2, our negative 3x minus 1 on the left. So our negative 3x goes on the bottom, and up above that goes our negative 1. And our area for our 3 is going across, so we have our x squared plus 2x minus 3. Now it's time to multiply, but as you can see, we're going to multiply 6 times instead of 4. So negative 3x times x squared is negative 3x to the third. We have negative 3x times 2x, which is negative 6x squared. Remember, x times x is x squared. We have negative 3x times negative 3, which is 9x. 2 negatives make a positive. We have x squared minus 1, which is negative x squared. We have 2x times negative 1, which is negative 2x squared. And we finish up with negative 3 times negative 1, which is positive 3. Now we're going to go ahead and write it as a finished sentence, combining any like terms that we have. So we don't have any negative 3, we don't have any x to the thirds except for the 1, so that's just going to head on up alone. However, I see that I have a couple x squared, so I'm going to combine those two. And as you can see, I also have a couple x's. So as I'm writing my sentence, I'm going to combine those as well. So I have negative 3x to the third power, negative 6x squared times plus negative x squared is negative 7x squared. We have 9x minus 2x, which is positive 7x, and then there's nothing to combine my 3 with. So the answer to this problem, which is a binomial times a polynomial, is negative 3x to the squared, negative 3x cubed, minus 7x squared, plus 7x plus 3. As always, we're going to get a lot of practice with this on our Desmos activity today.